All right. Welcome everybody to this month's Trino America's meetup. Today I am joined with a familiar face. You all might know him. His name's Manfred Moser. Hey, Manfred.
Hey everyone, nice to meet you. Being here again in different channel, same show, same coolness, right?
You are on the right place. This is not Trino Community Broadcast.
as long as Brian and Commander Banban are around, I'm happy.
Yeah, that's right. He's sitting right back there, checking over my shoulder, make sure I'm doing all the things right. So I wanted to bring Manfred on today because. And just to let everybody kind of a public service announcement, I will be on leave probably starting, I think it's going to be like around next March. It depends exactly because I am about to have my second baby. And so I needed somebody to fill my spot. And Manfred came and was like, ready to take the challenge. So I wanted to bring on Manfred today, and we're just going to kind of do this Trino community broadcast style. Just start going through a little bit of the slides and intro the a little bit of the people that we have joining us today. So
yeah, it's been exciting. I'm looking forward to hear what Shopify is up to.
Yeah, so we're definitely having, as Manfred just mentioned, we have Shopify here today, specifically Noam and Eva. Tell me how to say it right later when we bring you on, Eva or Ava, and I'll try to stop embarrassing myself right now. Okay, so they'll be joining us today talking about the Shopify Trino testing suite. This is really interesting because a lot of times we're talking about Trino query performance, and we're trying to talk about like the ecosystem, how everything's getting pulled together, and then you bring up testing and you're like, oh, okay, but you think about it, to actually enable Trino to be running at scale, does anybody feel comfortable getting Trino, deploying a Trino cluster that can't handle the load that's actually that's actually going to get thrown at it in prod? I've had a whole bunch of these scenarios where, in my older jobs, where I would test everything on kind of a QA cluster or an integration cluster, and everything looks like it's going fantastic, and then you just put it into prod and it just sinks. There's some cache that you had somewhere that you just changed a couple things on, and then all of a sudden it just falls over, and you're like, wait, why didn't that fall over in testing? Well, it's because we didn't do the proper load testing and make sure that it actually could scale up to prod. So I've had all these kind of scenarios where they've affected me. I'm sure plenty of people that are listening in right now have also been affected by this. Please do tell us if you have an interesting story about this. Just see if you can briefly summarize it, and we'll bring it up on the meetup here. But enough with that. Let's talk a little bit about what we're doing today. Manfred, what can you read the screen and tell us what we're going through today?
Well, we're talking about the Trino community as always, and I see that Damon is joining us from Ottawa again. So of course, we talk about the Trino community, which is great. We span across the globe, including fellow Canadians like Damon, and of course lots of people around the globe,
as well as Eva,
including Shopify is also, yes. I guess, over there somewhere as well, right?
So cool.
And then we'll talk a bit about Starburst and Trino and our work together.
Awesome. And then tuning in is Rose. Hi, Rose, from Florida, getting that tan. Cool. So that's basically what we're doing. So I'll cover the first half, and then I'll let the docs guy do his little pitch here at the end. So to begin with, if you're new to Trino and you don't know where to begin, and kind of it's great enough that you found this and you're listening to me talk today, whether you're here live during the meetup or whether you're listening after the fact. Welcome to the Trino community. We definitely are happy you're here, and you're super wonderful looking and smart for having chosen this Trino community. We like to pride ourselves on the fact that we are very open to new folks. Oh, hey, Rafael from Brazil. And so we definitely are wanting to make you feel welcome. And so sometimes it's kind of hard to make out where do I begin? So easiest thing that we like to point everybody to from the get-go is our Trino Slack. So if you go to trino.io/slack.html. The links, by the way, here are going to be shared out in the chat here shortly. So don't feel like you need to start scrambling down and writing out all of these. But if you go trino.io/slack.html, that will go to a page where you can find the invite for Slack. Go there, sign up there, and this is primarily the biggest place where you can kind of get in touch with people who are actively deploying Trino. The wonderful folks we have here today, Eva and Noam, are both on the Slack forum. So if you want to ask them questions afterwards, also another great place. And then just all of the experts on people that created Trino, including Martine, Dane, and David, myself, and Manfred, people that live, eat, sleep, and breathe Trino. That is kind of all the people that you'll find and run into on Trino Slack. And real fast,
don't get overwhelmed. By the way, yes, there's a lot of pros there, but there's also a lot of newbies, and even the pros, there's always subjects that we have no clue about, including myself.
Oh yeah,
always learning something new there. So there's plenty of different channels around where you can chime in for questions on beginners, expert demos. You can also talk about releases, development problems, and anything else. So this is a very open community, and there's, I think, didn't we just recently hit a cool number there, Brian?
Yeah, we just hit 6,100 members in the in our Slack channel number. So I mean, the cooler number, I guess, is 6,000, but 6,100 is 100 more.
It's going so fast, right?
Yeah, I think that was only like a week ago too. So I think like 100 per week kind of rate we're hitting right now. So pretty wild. So outside of the Slack channel, definitely a fantastic resource. We have a beginner channel too that you automatically get added into there. So if you feel timid about asking questions, ask them in the beginner. That's the whole point of the channel. So then there's also a show that we were just alluding to called Trino Community Broadcast. That's trino.io/broadcast. That is the show that me and Manfred host on a monthly basis now. And it's a kind of a similar forum to Meetups, but less about like having somebody join us and do their own presentation. We actually kind of go into specific concepts that Manfred and I will research a little bit beforehand, dive into those concepts, and then, likely bring on someone from the community or not. Sometimes we also just like talk about it ourselves and have them talk about that concept, have a use case or an example of that concept at scale in Trino. And then so definitely check that out. That's also coming through on the Trino YouTube channel. And so you can subscribe there if you're interested. We have one coming this Thursday where we're going to be bringing on Goldman Sachs talking about high availability. So definitely tune in for that one. That's going to be a lot of fun. Trino virtual meetups. If you are here at one of those listening to me talk about this, if you're listening on YouTube, there's also, you can go to the meetup site so that you can subscribe and kind of find out when the next upcoming meetups are and what they're covering. And so that those will be happening every month. They're split up by time zone. So if you're in EMEA, if you're in APAC, we're going to be ramping those ones up a lot more in the upcoming months. EMEA is definitely coming. I know I've said that a couple times in previous ones, but we really are getting those off the ground. So so that being said, Manfred, how do folks contribute to this project? If they want to, if they know how to code maybe and do a little bit of Java stuff, they can do that. Or if they want to, write up a little bit of docs, how do they get started?
Well, we are a very open community, so it's very easy to get started on the trino.io website /development. You can find out more, but essentially you can just start with very simple feedback by chiming in on the Slack channel. And then if you notice any problems that you would want to contribute, you can just send a pull request. You'll probably have to learn a bit about GitHub and stuff like that. A good place to start is the documentation where you can just, find a spelling mistake and fix things like that. Yeah. And on the link that we have there, github.com/trinodb/trino, master docs, which is the directory where the docs is, there is a README that explains more about that. And there's also 2 YouTube videos that show you exactly what to do, how to start up the CLI, how to run the build for the documentation, those kind of things. But in general, just bring your ideas and feedback. And if you want to dive in more, there's a lot of help available on Slack and also in the website in development on like contributor license agreement and like coding style and all that kind of stuff. Like as complicated as you want it, but also as simple as you can handle, right?
Yep.
So you don't have to go into the depth. There's a lot to learn, and it can be very fun and challenging, but you don't have to go all in.
And as said before, if you're confused about how to start, you can reach out to myself or Manfred, and we can definitely help you out in getting started there. So one other resource I like to make people aware of is there is a Trino Forum. We are going to be hiring a community manager. So if you have a somebody in the that or if you are that person that enjoys kind of living in the community, like enablement and trying to basically help get answers for people, help people out in general, and things like that. We would definitely like to. We have an open head count, and you can reach out to me again to talk more about that position. And essentially, what we were trying to build here is a central kind of knowledge repository of all the great things, conversations happening on Slack, on Stack Overflow, and kind of centralize them into one spot so that people can quickly find their answers and have it, quickly be shown on Google searches and stuff like that. So building that up now, and definitely go check out trinoforum.org if you haven't yet, and sign up, hoping that we can get, somebody community-wise to lead that effort there. Finally, if you haven't been to one of these before and you want to be getting some really cool Commander Bun, which is what we named our little bunny guy, swag, Manfred is repping it right now, then do follow the link that we sent out in the comments down there, and we can you basically just fill out the form and we'll be able to get you some swag there. And there it is right there. So definitely set up, click on that link in the comments and go grab your free Trino t-shirt. Any questions, of course, as we said, ask on YouTube right now for the talk today. Ask on Trino Slack afterwards if you're watching this on YouTube and you want us to answer your question there. And then, as usual, follow us on Twitter at TrinoDB, and you can also ask questions directly on there and just tag us, and we'll find you that way. So without further ado, let's hop into a little bit of information about our favorite query engine and the amazing company that builds around it. Neetu, could you tell us a little bit about what is Trino for those that are new to this space, and then what is Starburst?
Absolutely. Thank you so much, Brian. Welcome, Manfred. You're a fellow Canadian, so we're gonna do just fine, right?
Taking over today.
Exactly. So I'm gonna start presenting. For those of you who are joining us for the first time, I'm super excited to be a part of this open source Trino community, and obviously looking forward to building this community as much as possible. So thank you for joining us today. I'll start with a quick introduction. My name is Neetu Goswami. I cover all of the enterprise data native organizations in the East Coast at Starburst. I've been with the company for about 7 months. And prior to this, I spent 2 years at Databricks. So I did a lot of those open source Spark meetups and built that community, helped our organizer do that. And I'm hoping that we can do that over here as well. So thank you again for joining us. I'll be spending a little bit of time on what is Trino and what is Starburst. So, if you have any questions, absolutely feel free to put that in the chat. And after I'm done, I'm happy to introduce you to the team that's joining us from Shopify today. Okay. So first of all, what is Trino? Brian's given a good context of, where all can you reach us? How can you actually be a part of the community, but also how can you, make some contributions to the community if you like. But it all started in 2013 when Martin Dane David joined the infrastructure team at Facebook. Facebook, with the army of data users, they were faced with a massive challenge. They had a massive Hadoop data lake and a big cluster, but the data users just couldn't, scale their queries, right? So that's where Martin Dane David actually created Presto to actually solve these challenges that the data users were faced with, right? So I'm going to get into what were some of those challenges, but Martin Dane David today are actually part of the executive team at Starburst, and we're still 100% committed to the open source Trino community, and continue to support the community and be a part of the community. So these were some of the challenges that Trino is set to help organizations with. Number one, it's a high performance MPP SQL query engine. So ANSI SQL being the most standard format of SQL, you can leverage that and use Trino as a single point of access to enable your data users, whether it's data analysts, data scientists, to continue using whatever tools they're using, but really simplifying and giving them that scale and concurrency that they need to get some of the analytics, which is in distributed data. Okay. Number two, separation of compute and storage. So Trino does not store anything. It's totally separation of compute and storage, but it provides that horsepower, that scale, that compute you need to derive data from distributed data sources. So your data sources could be on-prem, in the cloud, multi-cloud. You're actually able to do all of that, like federate the queries with that scale, concurrency, and separation of compute and storage. It is a community-driven open source project. I like to call it like the de facto for big data and ad hoc reporting use cases, but you can deploy it anywhere. You can deploy it in Kubernetes, cloud, or on premises. As good as Trino is, there were some requirements that were not being addressed by Trino. And I think that's the reason why the 6 of our co-founders actually created Starburst. Good thing is we are a distributed query engine with Trino at the core. So Trino is still the engine. We're built on top of it. We are the enterprise edition to the open source Trino project. Okay. So the way when we say like some of the efficiencies or some of the out of the box optimizations that you can find in Starburst is, number one, I like to call it's the enterprise grade Trino. So you get everything that you get in Trino, but you also get that scale, the security. So out of the box, you do get Ranger built in the Enterprise Edition Starburst. So, the role-based access control, row level, column level security, data masking is something that you actually get out of the box in Starburst. Performance and best-in-class support. We do have additional connectors, which you will find in Starburst, some very, very popular parallel connectors, super popular in any ecosystem or any architecture that I've seen. So those are some of the enterprise additions or optimizations that you will find. And of course, the 24/7 support, which is very, very critical for some of the large scale organizations. We actually have been selling at Starburst for the last almost 2 years now. But we already have close to 200 enterprise customers. Some of the logos that we have as customers, testament that they were using Trino before, but because of some of the scale and enterprise security that they needed, they opted to get transformed into a Starburst customer. But that number actually has to change. We have raised another round of 250 million funding by many key investors. So almost a $500 million raised, but continuing with our R&D and continuing with helping and promoting our customers wherever we can. We are customer obsessed. We're helping customers globally today. And have come out with the SaaS offering, which is called Starburst Galaxy. It's completely cloud native, frictionless, and fully managed. Good thing is you can actually connect to different sources within minutes. Okay. So with that, how do we actually do it? That's one of the questions that I get, asked a lot. So we're sometimes referred as the data consumption layer, sometimes the abstraction layer. We are the analytics engine for data mesh, which is becoming very popular today. But essentially, we sit right in between the tools your data users are comfortable using. So BI tools like Power BI is a big one, Tableau, Looker, ThoughtSpot, Click, or your data scientists, whether they use Jupyter Notebooks, Spark, or Python, they continue using those tools. We essentially provide you, like I said, with that horsepower, with that consumption layer. Using SQL, with one SQL statement, they can actually hit the different sources you see at the bottom. So we sit right in between the tools and the sources they need to derive insights from. As you can see, it's a good combination of data lakes, relational databases, NoSQL stores, stream databases. But essentially, it doesn't matter where you're ingesting the data from and where is it landing today. If you have that data lake and you want to derive quick insights from that with that scale, concurrency, and that governance, then definitely take a look at Starburst. But if you also have some federation needs, like connecting to Kafka topics, or you have a data warehouse and your data users are often looking to combine insights, but are they're not able to, or it's delayed because of ETL pipelines, that's another really good use case for us. With that, I want to thank you all for your time. Absolutely feel free to get in touch with me on LinkedIn if you have any questions, but I'm happy to introduce and bring on Noam and Eva from Shopify. Welcome, guys. Happy to have you. And I'm going to stop sharing my screen.
Eva, how do I your name?
It's actually Eva.
Eva, dang it. Eva. I knew I was saying it wrong.
Yeah, it was close. Don't worry. It's surprising the number of different ways that you can pronounce those 3 letters. But yes, Eva.
Okay, wonderful. Thank you for that clarification.
No
I'm hopping
problem.
off now.
Welcome, guys.
Thank you. Thanks so much for the great intro. We're so excited to tell you all about Shopify today and about how we're testing Trino. So let me get started with what is Shopify and what do we do at Shopify? Well, it's an e-commerce platform, and we're here to help entrepreneurs power their online and retail stores. We can tell you some metrics about our business. Our scale grows each Black Friday and Cyber Monday. So our latest milestone in 2021, we had 1.7 million merchants who made $2.9 billion in sales just in that weekend. And I'm Noam. I'm on the data reliability team. And I can tell you a bit about what that is. Well, we kind of work on reliability for Shopify's data platform. And what does that really mean? We partner with application developers who are, for example, working on Trino or internally made applications. And we develop new resiliency features, and we go on call, and we kind of just make everything more reliable so that the people working on the applications don't have to think about that as much. They have us who are kind of consulting on this problem, and as a whole, trying to make our data platform more resilient.
Cool. So my name's Eva. I work on the same team that Noam does, data reliability. At the beginning of the intros, we kind of talked about people that are new to Trino. That's me. I had really not touched Trino apart from knowing that it kind of existed in our data pipeline until this project. So I can talk about this, but don't ask me any complicated Trino questions because I'll probably just kind of shrivel up and panic. So data reliability is a kind of a really cool place to be working right now. We're sort of a brand new team. We were spun up just in the last couple of years. We take a look at tools and services for both data engineers and data scientists. Big concept that we have sort of is to make sure that the data is flowing really well through the pipelines to our data scientists, because delays can cause impacts in analysis, which can also cause impacts in our merchants' ability to sell, our merchants' ability to take a look at analytics and things like that. We are a very, very merchant-driven company, so we try to keep that as a big theme in data as well. And this year, we are looking at all sort of steps of the platform, including Trino, to inject some more reliability there. So what kind of scale do we operate Trino at? So let's kind of give you an idea here. So we process approximately 2 million plus queries a month, and that is constantly growing. It represents about 500 gigs of data. And our overall goal is a P95 of query results within 5 seconds or less. Again, we rely heavily on Trino for data analysis, and we need to get that analysis done quickly, efficiently, and reliably. We have hundreds of users, and we have several different use cases for Trino. ad hoc querying. So if you just want to run a quick analysis, you can use the ad hoc cluster. Scheduled reporting schedules reports that we need to run on a regular basis. Batch data transformation, all kinds of use cases, which represent about a dozen purpose-based clusters on Kubernetes. We balance these clusters with a query routing service, and we use a blue-green deploy model to make sure that we have as much uptime as possible. Basically, we have an A version and a B version of every cluster. If we need to run an update, have an outage, something like that, we'll bring up the second cluster, route all the queries over to that cluster, and once the original cluster is emptied, we'll spin it down. So what does that kind of look like for us right now? So right now, we're sort of running at full speed constantly, trying to really catch up to reliability stories and things like that. And we would eventually like to get to a point where we're like, okay, we're finished all the big, really important parts of the story. And now we can start, kind of building on top of that. So Noam's going to go into what exactly the problems that we're hitting with Trino and why we decided to build this upgrade library to help us out.
Thanks, Eva. I'm going to talk about some of the problems that we were seeing with our scale. We like to iterate a lot and make a lot of changes to try to improve the performance of queries running on Trino. And that could be infrastructure changes or deploying new version upgrades, tuning configs, basically anything that requires a change. The problem is that we have this long timeline to basically deploy a change. We have, as Eva mentioned, about a dozen clusters, and it can take about a day or more to upgrade just one. So then it's a cascading effect. Our process is we start by merging an update to the code, and then we deploy a candidate cluster, so something beside production that has the change that we can test in isolation. And then we run through this sort of unstructured checklist of what we need to do to make sure it's safe to deploy to production. And our checklist was kind of not very well documented and could change day to day. Sometimes our engineers might forget a step or two or perform them differently from one another. So that was a bit of a cause for some unexpected behavior and things missed. If we did notice something in the checklist, we roll back our change. And that's already about a day or half a day wasted. So we don't like to do that. But then what's worse is if we do promote the candidate cluster to production, and then we notice a change, for example, data scientists are starting to come into our channels and complain about things breaking. It's a bad experience for users. And again, it's another waste of time. Here's what our upgrade checklist looks like. All the things that we need to keep in mind, such as user-defined functions, which are related to internal data concerns, such as finance or time zones or math. And third-party clients, we have a lot of different connections to Trino, so we don't want to break any of those. We don't want to make queries and reports slower than they were before. We ideally want them to be faster. We don't want to start having unexpected resource utilization. And if give or take a few more items, it's just a bit, this is like the most we've ever documented it. So that's why it's a bit of a problem. We have a relevant XKCD.
There's always a relevant XKCD for anything.
Yep. This one is really talking about how much time can you save per every 5 years, depending on how often do you do a task and how long that task takes. And we're kind of in the area of the bottom right here, where we have monthly, maybe a little less than monthly changes, and they do take a long time. They take the time of several engineers and across several clusters. So having some sort of automation really gives us the opportunity to save multiple days or weeks of time.
Yeah. So what was our solution to this? And just something I wanted to add quickly onto like what Noam was talking about is not only is it time saved for the engineers, but having a lot of downtime on our Trino clusters erodes the trust that we have with our data scientists. So the better we can make this process, the better relationship we have with our data scientists, and the better relationship our data scientists then have with Trino as a product. So that's also super important to us. So what was our solution that we came up with? So we decided to spend some time building a testing library for a Trino cluster. So pretty much if we have a checklist that we want to check every single time, instead of having someone manually go through each option and be like, okay, did A, B, C, D, we wanted to codify those. So we ended up deciding to use Python just because Python is a language that's familiar to Noam and I, and as a language that we use heavily in data platform engineering at Shopify. And there's also an open source Trino Python client available for the execution and monitoring of queries. So that was already built for us. Super great. So what does this look like in practice? We wanted to build out unit tests in PyTest for verification, benchmark, and profiling. That was our original problem statement. We eventually ended up, for the first take of this, for the first project we ran on it, bringing it down just to verification tests. And we'll talk a bit about why we did this. So the verification would be the idea of handling the checklists of items from before. So we want to be able to write a test that is a query that tests, one of our user-defined functions, or, runs a query and makes sure that the result is correct and that it doesn't error out. And the goal of this would be basically to have a single click thing where you're like, okay, run this, run these tests. And if these tests pass, we can have what's the right word?
Confidence.
Confidence. Thank you. I cannot speak the English language today. High confidence that our upgrade is going to go fine. So our whole goal is to make it as easy as possible to test a Trino cluster. What this looks like in practice right now is we have an Airflow DAG. And when we kick off that Airflow, just because that's, again, a common scheduler that we're using at Shopify, so it's something that we all know, it makes a lot of sense to run it off of an Airflow DAG. Kick off that DAG. That DAG then deploys our testing suite into the cluster and then proceeds to kick off the PyTest, which kicks off the verification tests, and then gives us back a yes or no if the tests passed or failed. What we would love to do was sort of part of the scope, but we ended up not doing it quite yet, is to have the upgrade process go automatically through. So we do also have Airflow DAGs to do the failover from cluster A to cluster B that we mentioned before. So it would be very easy to add that as an additional step. Do the test pass? Great. Just deploy everything on the new cluster and we're good to go. So where are we at? Where aren't we quite there yet? So we do have manual unit tests that are in code. We have example tests. We've built out a whole bunch of features in PyTest. There are a lot of great things that allow you to build, say, custom assertions, markers, things like that Noam will go into a little bit more detail in. And those allow you to sort of build, okay, I want to see if the query that I ran is equal to the query that I expected to do. So we built that into a custom assertion. And the goal is to abstract as much of the specifics of writing a query and checking the results away to make it as easy as possible to develop tests. We also have a goal that we would like to start looking at this tool to use for benchmarking and profiling, but that's a bit of a harder use case than verification, because verification is like a checklist of things, whereas for benchmarking, we would want to run this over and over, store that data, and then analyze that data to see how our Trino clusters are performing over time. And we just haven't quite figured out the right way to do that, where to store the data. There are a couple additional concerns, but because this testing suite is essentially a query replayer, or a query player, sorry, we just tell it to run some queries, it's super extensible to be used for different things. And Noam will jump into some of the specifics that we built.
Right, so we were thinking about who our users going to be. They're probably going to be engineers working on Trino, and as Eva mentioned, everyone is very familiar with Python. So we thought we're going to use a PyTest interface to basically test our cluster, and we write tests in a very simple way without having to think about everything that's going on in the background. That's what the library that we worked on powers. And then here's some samples of the unit tests that you can write and the capabilities. To start off, we're doing one, just kicking off a query from a laptop to a candidate cluster, checking, is this query returning the result we expect? So you'll notice there's a mark. We've marked all our verification tests or correctness tests together, so you can run them all at once and ignore any other tests like performance or benchmarking. Then we've passed in this fixture, which called candidate cluster, which has all the client information and connections and built-in functions to run whatever you need to run. So we run select one, and then we have an assertion. The rows that were returned were exactly what we expect. So now to get a bit more complex, we have the same query being run against the candidate cluster, which is the one we're testing, the change that we've deployed, and the standby, which is more of a control cluster, which is a clone of production. But it just doesn't have any other traffic on it, so we know there's no interference. This one, we've marked it as performance, and we pass in two fixtures, candidate cluster and standby cluster, again, with all the client's information. And then we have this built-in function called multi-cluster. So we pass in the clusters we want to run on and the query. Again, select one. And next, our custom assertion. Are the results equal within a time threshold? So we want to make sure that performance hasn't changed too drastically. And again, they should return the exact same results, depending. It doesn't matter which cluster they're on. Now, I know that benchmarking is a big thing as well for databases. So we built some benchmarking as well capabilities. This one is, what's really cool about Trino, they have this Tpcds connector, which is kind of like a modeled data generator that generates data deterministically. So you can generate a database of different scale factors, or SF, as you see here, showing the number represents the number of gigabytes inside. Generate one with sample data of 10 gigabytes, 100 gigabytes, or terabyte. And then it's highly relevant structure to the type of data that we have at Shopify's data warehouse. And that's why we decided to use it for benchmarking. First, we parameterize the tests, meaning we repeat the same test on different scale factors. And then we pass in the fixture, again, candidate cluster, and we run our list of open source Tpcds queries. So after that, you can actually assert on all kinds of things like performance or correctness. Basically, the result should be the same because the data is generated deterministically. We might want to use this kind of example when we're testing config changes and seeing optimizing for certain types of query performance. Okay, again, here's one more example to show you. We noticed a pattern in our ad hoc usage of Trino where data scientists will log in during the day, run ad hoc queries, and then at about 5 o'clock, most people log off. And there's not a lot going on in the cluster overnight, but we've still scaled up to as high as we have. So what we want to experiment with is, can we scale down overnight and maybe save some money? We built an auto-scaling algorithm, and we wanted to test that. So the author of this algorithm used this high to low kind of profile of traffic, where you can say, all of a sudden, we have a lot of queries, and then they taper off. How does our algorithm respond? Does it scale properly? Again, we also have this replay notion where you can take two timestamps, and not to get too into the details here, but we do log every query that we run. And so we can take a whole day's worth of queries, replay them all in parallel at the exact same time that they ran, and try to replay a single day. Then we can say on this, with this cluster, taking the same day on two different clusters, which one performed better?
Yeah. So how did this all go? We definitely sort of rate it a thumbs up. There were wins, but the tool hasn't been as widely used and adopted on the Trino team as we would like it. So we do have some verification tests in there, and it has been used to do some Trino version upgrades. But more work still needs to be put into figuring out exactly what do we need to verify. And I think that was a big struggle when we started writing this. We were like, what queries do we actually need to write to make sure that an update is safe? And so that's something we're continuing to work on and hope to add to the tool to make it more useful. What was interesting is we did see it used a lot for we did see it used for experimentation, like Noam mentioned, to replay a series of queries or to kind of just flood a cluster with queries at a specific interval. So that was an interesting use case for it. We also were able to use it for load testing for Black Friday, Cyber Monday. As you can imagine, we get a lot more flow of data from that weekend than any other time of the year. It is shockingly popular to shop on Black Friday and Cyber Monday, especially now that you shop online a lot. And so doing load testing for our data tools is super important to make sure that nothing will topple over during the weekend or after the weekend. And so we were able to do that, to do some load testing on Trino, which was very helpful.
So I'll just give you one more quick case study. We had our support team who is using, they need to run reports on basically how they're supporting merchants. And they were on a legacy database that wanted to migrate to Trino. So they said that they have a very high number of support workers, and we didn't want to just say, okay, starting right now, go ahead. It could be risky, it could affect other queries running, things might fall over. So we said, well, why don't you give us a representative query, representative report that you'd like to run, and we'll do some tests for you. And basically we spun up tons of queries, hundreds, all at the same time in parallel, to try to see what limits were on our cluster, what we needed to change, and if this was even possible. So this was really cool for us because we found some configurations to tune, like subgroup concurrency, group concurrency, max request queued, and threads in our library, in our testing library, that we had to increase as well. So overall, we decided we're going to make them a purpose-based cluster with specially tuned configs for them, and everyone was happy, and they migrated successfully.
So before I dive into the slide, I just want to share that while we're talking, I ordered my swag shirt, so I'm very excited for that. It has a bunny. I think this is fantastic. So thank you for that. So what's next for us? So we've kind of built out the space. We're seeing some use for it, and we would like to kind of continue on that momentum. We would like to integrate it more with our upgrade process. What would be really, really cool is if we could just have one-click upgrades where if the tests pass and we trust the tests enough, we can just continue to an upgrade. And that's something we'd like to work towards. We'd like to put a lot more effort sort of into load tests, benchmarking, and profiling. What we would love to be able to do is have regular batches of queries run on our Presto clusters and then store the information about runtime, things like that, and then be able to store it then in our data warehouse and be able to analyze that. Schedule testing would be fantastic. But really what we'd like to do is we'd like to open source the library code that powers the tests, because we would really like to get some feedback from the community, see if other people find that useful, see if other people, have ideas for it. Like, that would be really cool to kind of give back to the community and be able to open a feedback loop there. And speaking of the community, so we're talking about something very, very specific in terms of the Trino testing library. But there's going to be some future deep dives by other folks on the the Trino team that deep dives into Shopify's Trino infrastructure and sort of our performance experiments and things like that.
Yeah, so thanks again for watching, and thanks to everyone for having us. We'd like to share that we have an engineering blog. So there's lots of cool stuff. There's some more details about Trino scaling as well. And we also have a Shopify Twitter. We tweet a lot about data engineering too. So I'd like to open up to any questions or anything.
Yeah, wonderful presentation there. Thank you so much, Noam and Eva. I'm blown away by the level of like thought process that's gone through, specifically seeing all, like, you know, not only are you at this level, a lot of people are just getting to this level of like high availability, having multiple clusters and being able to swap those out. But Shopify's, you know, you all at Shopify and your team specifically has kind of taken this whole other approach about kind of getting into a process of automation around making sure that any small incremental change is being detected. And it just blows my mind. So Manfred and I have a lot of questions. I'm sure, like we typically generate our own questions. So I want to quickly tell everybody who's kind of tuning in, please send your questions. But for starters, I think Manfred, if you want to, like, I know you had a couple. I'll reserve mine because I always talk. So you're on mute, Manfred. Manfred, you're on mute.
It's an easy question. Wow, this is not challenging at all.
Don't you worry, I got more challenging for you coming right up. So I'm especially surprised that you're using like an automation tool for your deployments, like Airflow, for example. In this case, Apache Airflow, definitely a cool tool. What are you deploying on though? Like, right? I mean, it's nice to have automated deployment, but what's the infrastructure you're deploying on? How does that work for your situation?
I can take this one.
Yeah.
We are a customer of Google Cloud, so we use their Google Kubernetes engine, and we have our own clusters basically for this. We have different namespaces for different clusters, for different Trino clusters, and we will do some more deep dives. So we will get some more information about that soon.
Cool.
That's cool. But you're basically running on Kubernetes with your own tooling, and doing that in the cloud. And then how many
cutover look like?
You running a lot of clusters there, or just like a handful?
Cool.
We have about staging and production clusters for about each purpose-based thing. So we have one just meant for scheduled reporting, one meant for ad hoc usage,
Okay, so there's a couple.
some for experiments, that kind of thing.
What's the cutover look like? If you can elaborate on this for now, but like, let me know. What's the cutover like when you've ran through the experimentation and it's time to cut over to the other thing? Like, what does that look like? I know internally you all on a blog that you posted a while back talks about using the Presto gateway, Trino gateway, whatever you want to call it. And so is there like a special thing that you have to do to hack the routing to do that cutover? Or is that something internal at Shopify, or is it still something in the open source gateway tool?
Yeah, it's pretty much based on that gateway. And we have two clusters at once, as Eva mentioned. So we have the green one that's always up, and then we just mark the other one as production ready. And like we have a limit on our query time execution. So as we just slowly drain them over to the new one.
Okay, gotcha. So as like basically you'll flip the switch, they start moving to the new cluster, and then once you basically have determined that all the queries have ceased existing on the old cluster, you'll tear that one down.
Yeah.
Awesome. We got a question here from Fabricio from Brazil. On the slide with the pie chart showing the query workloads, you do have DataGrip and Trinity BC as different workloads. Is there any reason why? So it looks like, I'm guessing DataGrip, you'll use JDBC to connect there. Is there a particular reason why you segment those out, or is it just kind of just to know where specifically what tool is being used more frequently?
Oh, that's a good question. What I think it is that we do have some like custom built software that interacts with Trino as well. So data grip is technically more of an ad hoc usage for us. So we just want to differentiate those.
Okay. And the second part of his question was like, are there different queries typically that go through those two different modes, I guess you would say?
Yeah. So it's more like ad hoc data scientists using data grip, and then we have more like I guess it's production level, like tested queries written in software.
Okay, cool.
I saw that you seem to be using, like, there was RubyMine and IntelliJ. So you have a bunch of developers basically that use the JetBrains tools, including DataGrep and stuff, right? They all work via the JDBC driver, but they are probably separate audiences stuff. Yeah. It's quite impressive in general. I think that you have a lot of different clients being used. Like there was also this mode that I saw, and some slice and other things. So it's quite diverse. So is there any like particular challenges you've observed over time from having like a whole bunch of internal users using all sorts of different tools?
That's a good question. I can't say from my point of view, because from sort of the data reliability story, we're not too concerned with, what tool it comes from, mostly how it operates once it hits the cluster. But Noam, you might have.
I think one thing that we do care about is the user attribution. So which user is running which query. I guess the more clients we introduce, we have to make sure that we can still keep track of that.
Fabricio has a follow-up. So basically, to help on workload management, help better query distribution among cluster. Does it make sense?
Yeah, as well. Yeah, we route based on the user, and we try to log who the user actually was.
And it also, right, there's like for us a big differentiation between sort of ad hoc queries and production queries. And on our production clusters, we kind of have a steady flow of queries, and we're able to sort of schedule resources around that and have a good idea of that. Whereas ad hoc, someone can, flood queries, or we'll have quiet times or things like that. It's not always like a static usage. So having that differentiation helps us a lot to make sure we don't end up starving production from resources. And then if we need to scale up for whatever reason to hit a spike, we have the flexibility to be able to do that.
We got a quick thanks from Fabricio. So thank
you for the question.
Yeah, thank you.
I also wanted to know, like, do you typically find that you'll leave like multiple versions kind of hanging around for various reasons? Like, do you have like, I'm trying to think of a use case, but I was thinking like, the possibility is that you just leave a couple sitting around, but I'm wondering if there's like, or do you try to pretty much stick to like, okay, we're moving to this version, like everybody in prod, we've done all the testing and everything, like everyone in prod now moves to at the same beat. Is that pretty much how the progression works, or do you keep older versions around for any reason?
I think that we do everything at once because just to make operational work a lot easier.
Yeah, it's never this question of like who's running what version or anything like that.
Yeah, there's always like a risk of some kind of corruption if they're running different things and they're interacting. So I don't know too much about that, but I think that it can be more beneficial to do it all at once.
So when it comes to these switches of your clusters to different versions, I noticed that you're talking also about user-defined functions and stuff like that, and obviously they're Java-based and they hang off the service provider interface in Trino. So who manages those updates? Like, it's not just simply like updating the Trino version and Bob's your uncle and everything runs. You have to like adapt to the new API. You have to compile that plugin again. Is that your team owning that, or like how does that work? And like what's your experience in the interaction with the Trino community around those SPIs and stuff like that?
That's a good question.
I'd say that it's partially the team managing Trino, as well as they get some contribution from data scientists too.
Okay, so you have a bunch of them as UDFs and you work together on them, basically.
Yeah, that's from my knowledge.
Okay, cool.
Yeah.
We have a question from Super Chocolate Pain. I love that name. What's the longest running query you've experienced?
I don't know. What is the longest?
Oh, probably.
What's the longest? No.
Like we have limits, but we sometimes have to break them for metadata gathering of our clients that need to say like what are all the tables that we have in our warehouse.
That's a Hive query then, and that's I'm guessing, and that's probably like going over one of those longer scans, I guess.
Yeah, the scanning ones.
Oh, yeah. Well, and that's interesting too, because like we've been really interested in there's a lot of trends going towards using Trino as a more long running tool. We've talked to a couple companies, and obviously on last Trino community broadcast, we talked about Project Tardigrade, and this is kind of moving towards adding more features that kind of encourage users to use Trino as an ETL tool. It's always been an ETL tool, but it's always had this capability, but people feel more comfortable whenever you have these retry capabilities. And so I'm interested to hear like when, especially companies at your scale using it for these particularly like long running type of queries. We have another question that came in from Ritesh. Are you running performance benchmark and correctness testing for every upgrade or only a subset of those? How often do you do upgrades at Shopify?
I wish we were running that for every single upgrade. So
that's a good goal, right?
Yeah, right.
I mean, that's our ultimate goal, right? Our ultimate goal is to be able to, with have full trust in every single upgrade that we do, and know that that's not going to impact data scientists. They're not going to, break down. Right now, we do correctness testing. We do. But we can still really improve on that. Like there's a lot of additional like verification that we could add in there that would be super useful. And performance and benchmarking are concepts that we've kind of built into it, but we don't have quite we haven't quite built it in like yet. Like for performance, we would have to have that sort of running on a schedule and be collecting those values and then figuring out, how to store them and how to analyze them and what values do we really care about. And we haven't been able to invest that time into the tool quite yet, but that is the dream. Yeah.
I mean, you're already ahead of the curve with a lot of this tooling that you've built out. So, I'd be just blowing my mind right now if you were like, yeah, we do that every time.
You know exactly how every minuscule change impacts clusters.
So.
Well, I on the positive side of things, for all the people that don't have that kind of complex infrastructure in place, we do that for you to some degree, right? Like every Trino build does run a whole bunch of like tests, including performance and regression testing and stuff like that. Obviously, there is never enough of that you can do. And unfortunately, and that's what you experience, this also depends a lot on your custom deployment, like your UDFs and your specific workload. But there is a lot of testing and benchmarking going on in the Trino project. So for those of you that sort of like fly by the seat of your pants without any of that yourself, rest assured, we got you covered to some degree at least.
Yeah, totally. And also looking forward to the fact that you all are interested in potentially open sourcing this at some point, and would be really cool if once we do that, we can look into maybe doing like a blog post that kind of enables different teams to do this, because in this world of where we're really hitting out now, testing and data quality checks and all these other pieces. I mean, and DBT really drove a lot of that in their ecosystem, right? So that fact that we've paired with DBT now in a lot of ways has brought this up a lot more in our community. And I'm so glad that we actually got the chance to bring this up today and bring that awareness to folks that, it's one thing to get it out there and get it working, and now it's running super fast queries, but you want to make sure that you have, you've gone through and verified that there's no regressions coming in specifically with your workloads and your use cases. So thank you so much for sharing that with us today, Eva and Eva. Sorry, gosh, I know.
Okay, it's very difficult. It's very difficult.
And Noam, thank you so much for taking the time to present that to the community. How can people get a hold of you if they have any further questions offhand?
I'm pretty active on LinkedIn, so that's the best way to get a hold of me.
Okay.
Yeah, same with me. Trino Slack as well.
Awesome. All right. Well, great. Well, thanks again for joining us, and Nitu, as always, thanks for bringing us into the all of the Trinoobies out there that are just getting their feet wet on what Trino is, what Starburst is. Thanks everybody for tuning in today, and hope you all learned something. And make sure that go on to TrinoDB/Trino if you haven't yet. Give us a star there. Follow us on the YouTube channel on Trino, and definitely reach out to us on Slack. Thank you so much, Super Chocolate Pain. Keep joining us because I love your name, and that is hilarious. I'm hoping that elephant is an homage to Hadoop, is my guess, but not 100% sure. Okay, well, take care, everybody. We'll see you the next month.
Thank you, guys.